My name is Barbara. I have been a photographer for 18 years and I will be your instructor. In this course, you will learn the basics of photography, including what is photography. You're also going to learn about the exposure triangle, ISO, aperture, shutter speed. You're going to learn about JPEG versus RAW, light metering, and more. So what is photography? The literal translation of photography means drawing light. Most don't associate photography to drawing with light, but they should. As you will find in this course, photography is all about the light. As photographers, our biggest challenge is light. And there is so much to know about light, the quality of light, the color of light, the direction of light, and a lot more. The impact of photos are amazing. Our brains process visual images 60,000 times faster than written information. And through photography, we preserve history, our children walking and taking their first steps, endangered animals, decaying buildings, times of war, and times of passion. These famous images definitely give you a feel for the impact of photography and how capturing this slice of life is telling a story. It gives us a sense of what's past and of history. I believe we inherited the art of photography from painters who preserved history with a paintbrush rather than a camera. The exposure triangle. The exposure triangle is a visual representation of the relationship between ISO, aperture, and shutter speed. These are the three main components of exposure. This course is going to explain in detail what each one of these components do individually so you can better understand how to make them work all together. Think of your camera as a completely dark box, and the only way to let light in is with these three components: ISO, aperture, and shutter speed. All three of these components let light into your camera, and each do that in a unique way. You can relate it to a pie chart. When you take more light from one, it takes away from another. Understanding these components will help you understand how to get your total exposure, because each one of these components let light in, and they each have a consequence when they do. And that's what we're going to explore in this course. In the next segment, we'll start with understanding ISO. Understanding aperture. What is aperture? It's also one of the three pillars of the exposure triangle. It's also referred to as f-stop. It's actually a function of your lens, not your camera. Aperture is a diaphragm basically that will either expand for a wide opening, like you see on the lens on the left, or constrict for a narrow opening, like the lens on the right. It works just like the pupil in your eye. So where is your aperture? If you're looking at the back of your camera, it should look something like the visual on the left, with an F in front of the number. With a semi-pro or pro camera, you may only be able to see the top view. In the top view, you'll see that it's always to the right of your shutter speed and may or may not have F noted beside it. So of course we know that aperture is going to affect light, but it also has another impact that is really why we make decisions on our aperture. The visual on the left, taken at f2.8, has a shallow depth of field. That's where things are blurry in the background and only the focal plane is in focus. And that's attained by using the smaller aperture numbers, in this case f2.8. The visual on the right is a deep depth of field, and that was taken at f16. So the grass in the front, all the groomsmen, and even the barn behind are in sharp focus, and that's called a deep depth of field. So consider from the camera's point of view, all the way back to the furthest part of the image, how deep into your image is something in focus. A shallow depth of field is where you have a shallow area of focus, and conversely, a deep depth of field, you have a deep area in focus. Also note with a shallow depth of field that you can have something in the foreground out of focus until you get to the focal plane, and then the background is out of focus. So how does aperture affect light? Well, remember I said it works just like the pupil in your eye. When we go into a dark room, our pupils are going to get very big trying to get light in. And when we go out into the bright sun, our pupils shut down really small trying to block that light out. So the larger aperture openings actually give us more light. The smaller aperture openings give us less light. Now the aperture numbers might seem a little backwards at first. The smaller aperture number, like f1.4, the furthest aperture opening on the left here, is actually the large aperture opening. The larger aperture number, like f16 all the way to the right, is actually the smaller aperture opening. So if it acts just like the pupil in our eye, and we give our camera a very large opening with a small aperture number, we're getting more light. And conversely, if we shut our aperture down to a small aperture opening, large aperture number, we're going to get less light. Also remember that with f16, that smaller opening, we're going to get a deeper depth of field. Whereas with the smaller aperture number and the larger opening, we're going to get more light, but a shallow depth of field. So several things to be mindful of when we're adjusting our aperture. And it's important to understand what you're doing when you're changing your aperture, because if you were going to take a photo of 15 people and post them in 3 rows of 5 people, if your focus point lands on the first row, there'll be a nice, crisp, sharp focus. The second row, however, will start to get a little blurry, and the third row would be even blurrier than that. So to review aperture, smaller aperture numbers, wider openings, get more light into our camera. The consequence is a shallow depth of field. But sometimes that's not a consequence. If you actually want a shallow depth of field, that isn't a consequence at all. As photographers, our fight is for light. So anything that gets us light, especially without a consequence, can be expensive. Welcome back. This segment is on understanding ISO. And this tutorial is brought to you by Creative Online School. This segment is going to be on ISO. So what is ISO? It's one of the 3 pillars of the exposure triangle that we've already talked about. It's basically equivalent to what film speed was if you've ever shot film. It's how sensitive our sensor is to light, and typically ISO in cameras today range from ISO 100 to 6400 or more. Where is your ISO located? Well, if you have a view on the back of your camera, you might see it like the visual on the left. And if you have a view from the top of your camera, it might look like the visual on the right. You can locate it in your menu on some cameras. Other cameras, you might have an ISO button on top of your camera or on the back of your camera. Here's a basic guide for how to set your ISO. It says set your ISO to 100 for daylight, 200 for shade, 400 indoors, all the way up to 1600 or more for sports at night. Although it's a great guide, rather than memorizing that, you'll want to get an understanding that as you're getting into a darker situation, you're going to be raising your ISO number. Here's a visual of my dog in a room with a porch facing a window. Set at ISO 100, you just see the bridge of his nose and specular highlight in his eye. As I raise that ISO to 200, you see you get a bit more light. 400, a bit more. 800. And finally 1600, you see that he comes into even more light. So with this visual we can see just by raising our ISO number in our camera, we're getting more light as we do so. So remember in the beginning when I told you that we're going to talk about these 3 pillars of the exposure triangle. Every one of them lets light in, but they also have a consequence every time we let light in. So what are the consequences of raising light with ISO? Higher ISOs are going to yield more grain or noise in your image. You see these visuals here from ISO 100 to 6400, and as we're getting up into the higher ISO numbers, you're starting to see grain or noise, you may have heard it called. It's basically flex and modeling in your image and is ultimately a degradation of quality. So our goal is to always use the lowest ISO number that we possibly can for quality. Not that we're always going to be able to, but we want to stay at the lowest number that we can. If you ever shot film, you may remember that ISO 400 speed film was quite popular because it gave us light without giving us the consequence of too much grain. And be mindful that you might not see the grain on the back of your camera when you're viewing your images after taking them. You're really not going to notice it until you upload it into your computer and can see it larger, or when you go to print it. So what are some situations where you're going to have to use higher ISOs? That's going to be in churches, or in this situation, at a wedding reception at the end of the evening with very low light. Indoors, where it can be dramatically darker inside than it is outside. And especially sports that are done at a dim gym, or even football. Although the football field may be well lit with lights, it's still rather dim. When we double our ISO, we're literally doubling the light. You can see here from ISO 400, we doubled the light at ISO 800. Newer cameras or professional full-frame cameras that have a larger range of apertures will handle higher ISOs better. Typically, your most important investment is with your lenses. But in the case of ISO, if you have an older camera that has a range of ISO 100 to ISO 1600, ISO 1600 is going to have a lot more grain than a newer camera that has an ISO range of 100 to 6400. As technology advances, so does the noise reduction software used. So it is definitely something to consider. To review ISO, higher ISOs get more light into our camera, and the consequence is going to be grain or noise, basically a degradation of quality. This segment is on understanding shutter speed. Brought to you by Creative Online School. Shutter speed is basically a time value. It's a length of time that your shutter stays open. So when you take a photo and you press the shutter button, a shutter curtain actually opens and then closes. Most of the time, it's really fast. You hit the button, you hear click, click, and your photo is taken. You may have noticed a lag at times where it's not so fast, and that's really what the shutter speed is. It's a time value of how long that shutter is going to stay open. Here's a visual of what shutter speeds look like. At the top left, you see 1/125. That's 125th of a second. On the top right, you'll see with semi-pro or pro cameras that you're just going to see the number, but it's 1 over whatever that number is. So that's 200ths of a second at the top right. So it's always a fraction, unless you see it or not, unless you see these hash marks. That's actually a 6-second exposure. On the right here, where it has the hash mark in between two numbers, that's actually acting as a decimal point. So that's 0.8 seconds. Some camera models do that, others show the decimal mark. But that's not an 8-second exposure, that's 0.8 seconds. So how do you change your shutter speed? You're going to rotate your command dial. On a Canon, your command dial is going to be right above your shutter button. So you'll rotate that with your forefinger, and you should see on the display of your camera that you're moving your shutter speed, which is typically to the left of your aperture. Nikon is a little different. The command dial is on the back, so you're going to rotate that with your thumb. And as you're rotating that, you should see that you're changing your shutter speed, again, to the left of your aperture, as shown here. So as you're rotating that command dial, you're changing your shutter speed. This is a typical range of shutter speeds that you'll see in digital SLRs today. Anywhere from 8,000ths of a second, if you can imagine that fast, all the way down to 30 whole seconds, which is a long time to have your shutter open. So really we're talking about light with all three of these pillars of exposure, but before we talk about light with shutter speed, we'll want to talk about the effect that it has. So if you've had problems with blur in your images, shutter speed is your culprit. Faster shutter speeds are going to freeze motion. Like this image taken at 2,000ths of a second, you see the quarter dropped into the water and the water splash. It is a frozen moment in time. On the right, you see a slow shutter speed where you see the tail lights of the car are blurred. And that's a 2-second exposure. So the impact of changing your shutter speed really has impact on freezing your motion. So it's really why we make decisions on shutter speed, but of course it affects light as well. Here's a visual to give you an idea of the impact of shutter speed. The waterfall that you see here, taken at 250th of a second, shows pretty much the water droplets being frozen as they fall down. In the next image, taken at a 60th of a second, you start to see some motion blur. Even slower than that, at 1/10 of a second, you see even more blur. And a 1-second exposure, you see you're starting to get that silky waterfall look that you may have seen before. So really, how do you know when you're freezing your motion? Well, it depends on your subject and how fast they're going, but this is a typical guide that may help. At 250th of a second and faster, you're pretty much freezing motion. That was intentionally the first slide of the waterfall. But if you're shooting sports, things that are moving quickly, the go-to for sports is 1/1000th of a second. On the left side, at a 60th of a second and slower, you will have motion blur. In fact, it may be so slow that you're going to need to be on a tripod to avoid camera shake blur. That was intentionally the second slide. At a 60th of a second, pretty much anything moving will be blurry. In between there, you kind of have a missing area, and that could go either way. It really depends on your subject. So how does it affect light? Well, the slower your shutter speed, the longer you're leaving your shutter open, the more light that can be absorbed by your sensor. So the faster your shutter speed, the less light we're letting into our camera. So just to summarize shutter speed, to get more light into our camera, we would slow the shutter speed down. The consequence is going to be blur. So this segment will be on RAW files. So what is RAW? Basically, your camera shipped from the factory will shoot JPEGs. In other words, your files will be saved as a JPEG file. You also have the option of saving your images into a RAW file, and many cameras today will allow you to shoot JPEG and RAW at the same time. So you'll end up with two different files of the same image. So what is a RAW file? A RAW file, all information is kept, so it's a much larger file. A JPEG is a compressed file, so all the information is compressed into a smaller, reasonably sized file. A JPEG will typically be about 5 megabytes, where a RAW file is going to be more like 25 megabytes. So it's going to take up a lot more room on your memory card than shooting JPEGs alone will. JPEG files, the sharpness, saturation, and color have all been processed. In a RAW file, no adjustments have been made to it, so you need to process the image. Basically, you need to go into the darkroom and process that. A JPEG file is immediately ready for sharing or printing. A RAW file is a proprietary file to the camera and must be processed in a camera RAW processing software to be made into a JPEG before you can print or share. A JPEG image is clipped in processing, so some of the highlights and some of the shadows are clipped, so that information is lost. A RAW file, all information is available, nothing's been clipped, so it's easier to recover from a poor exposure with a RAW file. White balance is recorded as you shot the image with a JPEG. However, with RAW, white balance can be adjusted after the fact, as if you'd set your camera to that particular white balance when you took the shot. You can adjust your white balance with a JPEG as well, but it's just not going to be as perfect as it would be if it was a RAW file. Since you have so much more information with a RAW file, you have the capability to do much more than you do with a JPEG. The downside is the fact that it is a larger file. It does take up more room not only on your camera card, but on your hard drive. RAW files will also slow down your camera since it takes longer to write a RAW file to the card than it does with a JPEG. So if you're shooting in a high burst continuous shooting mode, shooting with JPEG only is going to be your best bet. Adjusting a RAW file is also non-destructive because you can always go back to the RAW file and change anything that you've changed before back to the way it was or make different adjustments. This segment will be on understanding histograms. First of all, what is a histogram? The histogram is a graph of your shadows to highlights. Basically, this graph is showing you the volume of dark pixels to medium tones all the way to your lightest pixels. Pure black is going to have a value of 0, and pure white will have a value of 255. Understanding the histogram can help you understand if you have a good exposure. I always like to see a little bit of white and a little bit of black in each photo, but let's take a look at the histogram and where we can find it in our camera. When viewing your image on the back of the camera, you can press the info or display or something similar like that to be able to view your histogram. You can also hit it again to toggle out of that view. Let's see if we can make it more sense looking at this black and white photo. We're going to zoom in really far until we just get pixels. And once we have those pixels up, you can see we have different shades of dark to light. And as if I hover over each one of those pixels, you can see in the Information tab what that value is. And that's going to be a value from 0 to 255, again, from black to white. So if I take the first pixel here, and that has a value of 77, and I take all the pixels that have a value of 77, which there are 3 in this particular photo, I'm going to put that on a line graph. We'll go back and take the next pixel, grab those, and put those on the line graph on their value. So you can see that it's really like a line graph that has values from darks to lights, and on the left side, it's the quantity of how many there are. So the number of pixels that we have in that particular value are graphed on that chart. And that's what creates our histogram. So what can we learn from that? Well, taking a look at this photo, it's a dark photo to begin with because it's taken at night. So you'll see a lot of the pixels are kind of clustered over to the left. When you see the hump of the histogram clustered over to the left, generally it will mean that you have an underexposed image. However, in this case, it's a night photo, and that's okay. So understanding what you have in front of you and understanding the histogram can help you understand what kind of exposure you have. Here's another extreme where we have so many white things in the image. We have a bride with a white dress taken against a chapel that has a lot of white values. So we're seeing that the histogram is clumped over to the right. Typically, when you see this, you're going to have an overexposed image, in other words, an image that's too bright. But in this case, it's okay because we happen to have a lot of white values. Generally, your histogram is going to be clustered up into a hump into the middle, sort of like this one. And this is a properly exposed image. We don't have any pure blacks and we don't have any pure whites, and we have a good exposure. In this image here, in real life, there aren't a lot of whites, but yet our histogram is clustered over to the right, depicting that we have a lot of whites. So this is an overexposed image and easy to tell from your histogram. Here's the same image properly exposed. You do have a big spike of white on the right side where the sky is too white, which is pretty much unavoidable because of the high contrast scene. Mostly what you want to know is understanding your histogram so that you can understand better whether you have a proper exposure, because when you're outdoors, you may not be able to see your LCD screen as well as you would like to. So viewing your histogram can give you good information on how well your image is exposed. Hopefully that helps you understand histograms much better. This segment will be on understanding light metering. A light meter is a device that allows you to determine the shutter speed or aperture of a particular scene. Just like the internal light meter of your camera, a handheld meter determines the amount of light in a given situation. As we've covered before, with photography, what we're truly recording is light, so to find the correct exposure, we need to know how bright the scene is. With natural light, our camera's internal light meter indicator will give us a reading, but with flash and studio lighting, the light meter is the only way to get an accurate and convenient measurement of the light emitted from our flash or strobes. Light meters in our cameras tell us how the camera sees the light through the lens, also known as TTL. It collects the light through the camera's lens and measures the intensity. Often you may have issues with high contrast scenes where there are much brighter parts of a scene than others. This can throw off your internal light meter, and the result can be an incorrect exposure, depending on the part of the scene the light meter was measuring. Light meters work in 2 different ways: reflected light and incident light. What's the difference between reflected light and incident light? Reflected light is the light that bounces off or reflects from your scene or subject back to the camera's lens. This is read by your camera's internal light meter. The incident light that is falling on your subject, is read by a handheld light meter. When using a light meter, it allows you to get a reading to measure the light falling onto the subject rather than the light reflected back to the camera. For example, if your subject is wearing all white, like a bride, then the light reflected back to the camera is going to be quite strong and can yield an incorrect exposure. The handheld light meter, however, will measure the light falling onto the bride rather than the light reflecting off of the bride, and the resulting exposure will be much more accurate. To use a light meter to read incident light, you need to slide the dome over the metering cell. You'll set your ISO desired in your camera and on your light meter. Then you'll set your shutter speed desired in your camera and on your light meter. And the light meter will give you a reading which will tell you exactly the f-stop or aperture for proper exposure. It returns a reading to produce a mid-gray without being affected by reflective, like white, or absorbent, for example black, subject matter. To meter your strobes in studio, a handheld light meter may require the use of a sync cable, but most light meter models allow you to press a button on the meter and it waits for the flash to be triggered to give you its reading. This is needed because of the relatively short duration of a flash. Once you've set up your scene in a studio setting, you will use the light meter in much the same way as before. You'll set your ISO in camera and on your light meter to ISO 100. You'll also set your shutter speed in your camera and on your light meter to 1/125th of a second. You'll hold your meter in front of your subject with the dome facing the camera. You're going to press the measure button. It'll blink waiting for the flashes to trigger, and then you'll trigger your flash. And you'll see here it gives us a reading of f5.6. The meter instantly reads out the correct aperture for the scene you have set up. The great thing about this is that you not only will get an accurate exposure, but you don't have to worry about your settings changing during your shoot, unless your model moves closer to one of the lights. Even though we have tools to correct exposure in Photoshop or Lightroom, nothing compares to nailing your exposure in camera. In summary, your in-camera light meter is a convenient tool, but using a handheld meter can provide much better results, and even results your in-camera light meter cannot provide, as in the case of off-camera flash or studio strobes. Acquiring a basic handheld light meter can be a fairly inexpensive investment that'll pay back huge dividends in acquiring accurate exposure.